Good evening, everyone. I'm Brahmanand Reddy, a Java developer with the Department of Veterans Affairs. Today, I'm excited to share how advanced observability is transforming healthcare IT system. In the next 15 minutes, we will explore why observability is the backbone of resilient distributed healthcare systems, diving into challenges, solutions, and real-world impacts. Let's get started. Healthcare depends on complex interconnected IT systems, but 73% of the organization lack comprehensive visibility into these distributed systems. These visibility gaps can lead to delays or disruptions in patient care. For example, this chart shows how 73% of healthcare organizations struggle with system blind spot. Advanced observability framework address this by reducing the mean time of the resolution by 84%. This means issues are identified and fixed faster, minimizing patient impact. Additionally, integrated distributed tracing with clinical workflows cut troubleshooting time by 67%, allowing IT teams to focus on proactive care. This graph highlights the dramatic drop in resolution time. Let's compare traditional monitoring with the advanced observability and see why this shift is critical. Traditional monitoring in healthcare often relies on basic system level metrics like CPU usage. Without context, this leads to fragmented visibility, reactive troubleshooting, and no correlation with the clinical workflows. For instance, a system crash might only be noticed after it delays patient care. In contrast, advanced observability provides end to end visibility across care pathways, unified tracing of patient journeys, and proactive analytics to prevent disruptions. It directly links system health to patient outcomes, ensuring IT issues don't compromise care. This dashboard shows how observability integrated metrics for real time insights. This is a shift in game changer for healthcare reliability. Healthcare observability is not just about tech, it's about patient safety and compliance. First, we need HIPAA and GDPR compliance, monitoring and encryption, audit trails, and role based access to protect sensitive data. Second, analytics must link technical metrics to critical outcomes so we can prioritize issues that affect patient directly. For example, a slow system could delay critical care, and observability help us catch that in real time. Here is an example of HIPAA compliance monitoring interface. Finally, high availability is non-negotiable. We need fault-tolerant system with 99.99% uptime and automated failover to ensure critical visibility. Even during outages, this requirement ensure observability support life critical systems. Let's look at the real world example of how this principle were applied. In one critical care scenario, unpredicted system latency across interconnected services was slowing response times, putting patients at risk. To address this, we implemented end-to-end distributed tracing with custom infrastructure across all clinic service boundaries. As a result, a 67% reduction in troubleshooting time, allowing us to resolve issues before they escalated to clinical disruptions. This means faster, safer care delivery. This graph shows the drop in troubleshooting time post implementation. This case study shows how observability directly improves patient outcomes. Next, let's see how observability performs under pressure, like during peak load. During high traffic period, peak time volumes, systems are under immense strain. Our data shows system reliability dropping by 75% at peak load without proper observability. This chart shows the reliability dipping as patient volume spikes. By implementing advanced telemetry collections, we achieved a 58% improvement in system reliability during this period. Real time adjustment based on observability data prevented service degradation, ensuring critical healthcare operations continued smoothly. This highlights how observability maintains stability when it matters most. Now let's explore how AI is revolutionizing observability in healthcare. AI Ops is transforming healthcare observability. First, predictive analysis can anticipate system failures 24 to 48 hours in advance with 93% accuracy, allowing proactive fixes before patient care is implemented. This model predicts failure with high accuracy. Second, intelligent filter reduces false positive alarms by 71%, focusing IT teams on clinically significant issues. Finally, automated remediation enables self-healing system, resolving complex issues in minutes and cutting IT interventions by 64%. This dashboard prioritizes critical alerts. AI ops make observability smarter and more efficient. Let's see how edge-based observability takes this further. Edge-based observability brings monitoring close to the point of care. It reduces latency by 83%, enable critical decisions in milliseconds. It also ensures continuous monitoring during network disruptions, vital for uninterrupted care. This shows edge monitoring in action. Additionally, local data processing enhances privacy compliance by handling sensitive data at the source. Finally, real-time anomaly detection at the point of care lets clinicians address issues before they affect patients. So, how do we implement this? Let's look at the strategy. Implementing observability requires a structured approach. First, assessment. For assessment, it requires audit existing systems, identify gaps in clinical workflows, and define healthcare specific requirements. Next, implementation. Deploying distributed tracing, integrate metric logs and traces into unified platform, and ensure HIPAA and GDR compliance. This workflow outlines our implementation steps. Finally, adoption. Train clinical and IT staff, foster a data-driven culture, and build a cross-functional responses teams. This strategy ensures observability align with the patient care priorities. Let's see how these components fit into a broader framework. Our healthcare observability framework has three layers: the technical metrics layer, monitoring infrastructure applications, and the network with the healthcare specific threshold for critical care. The business impact layer correlate system performance with patient outcomes, optimizing treatment timing. The compliance layer ensure continuous HIPAA and GDPR compliance with automated reporting. Let's wrap up with the key takeaways. To summarize, advanced observability reduces mean time to resolution by 84% and boosts system reliability by 76%, directly improving clinical outcomes. It must be a core architecture principle, not an afterthought. We need to link technical metrics to patient care and design solutions with compliance first. By prioritizing observability, we build resilient systems that save time. Thank you for your attention. Observability is the backbone of a reliable healthcare system, and I hope this presentation showed its transformative potential. Thank you.